This problem is related to the concept of impulse momentum as well as angular impulse and angular momentum. So question says, a thin uniform rod of length L and certain mass is kept on a frictionless horizontal table with a massless string of length L fixed to one end. Top view is shown in the figure. So we have a rod and length of this rod is L and it has certain mass, let's call mass is M, and this end is attached to a string. So this is the string which also has length L. The other end of a string is pivoted to point O, and this is the point where the other end of a string is pivoted. This means this is fixed. If a horizontal impulse P is imparted to the rod at a distance x, which is equals to L by N, from the midpoint of the rod, then the rod and the strings revolve together around the point O, with the rod remaining aligned with the string. So what is happening? So if we apply a impulse P at a distance x from the midpoint, so this is the midpoint of the rod, and x is equals to L by N, in that case this whole system is moving in a circle, and the rod and a string remains aligned. This means this is always aligned. This means at this point this line, after certain point it will come here, it will come here, it will come here, and it will come here. So whole thing will move as a like both are intact to each other. So there is nothing like slack of the string. So we have to find value of n, that is this n, so that this kind of situation will occur. Now how will you solve this problem? Now if there was no string in this case, and if you apply a impulse, what will happen? This system will move, because you have applied a momentum or you have applied an impulse, so it will change the momentum of this rod. Not only that, about this center of mass there is an angular impulse also, so this will create angular momentum, so this will start rotating, so this will move as well as rotate. But in this case this is fixed to a string, and that's the reason this whole thing is moving like a circle. It's like a circular motion. So there must be some condition on x so that velocity of this point, basically this rotational, the velocity of center of mass and velocity, this rotational velocity and translational velocity balances each other. Or you can say such that it makes such a condition such that this starts moving in a circle. So somehow you have to find that condition, and this we will do using angular impulse and impulse momentum equation. So let us try to solve this problem. So let us first write the impulse momentum equation. What is impulse momentum equation? That is, impulse is equals to change in momentum, and in this case impulse is P. And what is momentum? Initially this was rest, that is 0. What is final momentum? Let us say its center of mass is moving with velocity vcm, then it will have momentum of m times vcm. So we can write P is equals to m times vcm. Let's call this as equation 1. Now I can also apply angular impulse, angular momentum equation. What is this equation? That is, angular impulse is equals to change in angular momentum. How much is the angular impulse to this system? Let us find angular impulse about this point, because this whole thing is rotating. So, and this is, we don't have to consider weight because this whole thing is on a horizontal table. So weight will be balanced by the normal reaction. So angular impulse of P is equals to P times this distance, that is x plus L by 2 plus L. So this is angular impulse, and this is equals to change in angular momentum. Initial angular momentum is 0 and final angular momentum is I times omega, where I is the moment of inertia of this system and omega is the angular velocity about this point. Now let us find moment of inertia. We need to find moment of inertia about this point because we have taken angular impulse about this point. So moment of inertia of rod about center of mass is ml square by 12. So I know this term, but I have to transfer to this point O, that is parallel axis theorem. ml square by 12 plus mr square, that is r is the distance from center of mass to this point, that is L by 2 plus L. So that is L by 2 plus L, so mr square. So this is equals to 7 ml square by 3. Let's call this as equation 2. So what I can do is I can plug the value of I here, that is 7 ml square by 3, and this is as it is. Let's call this equation 2. Now what is the velocity of center of mass? So this center of mass is moving in this circle, that is at a distance of L by 2 plus L, that is 3L by 2 distance, is moving in this circle. And omega is given, so velocity will be r times omega. So that is 3 by 2L times omega. So velocity of center of mass is 3L by 2 times omega. Now we have these three equations, and using these three equations we can solve for x. So the first equation is impulse momentum equation, the second is angular impulse angular momentum equation, and third equation is the equation that relates linear velocity and angular velocity, that is compatibility condition. Now let us divide equation 1 and equation 2. So if we divide, what we will have? We will have P divided by this term, that is P into x plus 3L by 2, and this side I will have MBCM divided by this 7 ml square by 3 times omega. We can plug the value of BCM, that is 3L by 2 times omega, that is this term here. Same thing I have written here. Now you can cancel P, you can also cancel M, and if you simplify a little bit, this will be 1 divided by x plus 3L by 2, and this 3 and this 3, this will get multiplied, so we will have 9, omega gets cancelled, and L is here and here L square, so I will have L only, and 7 times 2, that is 14. So this means 14L is equals to 9x plus 27L by 2. This means L by 2 is equals to 9x. So if you take this side, so 14 into 2, 28 minus 27, that is 1. So I will have L by 2 is equals to 9x. So this means x is equals to L by 18. So this means n value, that is L by n is equals to 18. So this means if you apply a force or impulse at this distance, this whole thing will rotate in a circle. You can think of what will happen if you apply an impulse that is lesser than this value or larger than this value. So I hope you enjoyed this problem, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.